Hello everyone, welcome back to Math with Allison. Today we're working in our integration series, so we're going to be continuing partial fraction decomposition and talking about when we have repeated factors. So let's go ahead and dive into it. Here we have simple factors. So every factor in the denominator is unique, right? There's only one of them. So when we use partial fraction decomposition, we just split them up evenly. We have some scalar A, some scalar B. You go all the way down for as many simple factors as there are. So what's a repeated factor? It's when we have a repeated term. So right here we have x squared. So we have x and x. The question is, why is this an issue and why can't we just do it normally? So let's go ahead and try to do it normally, right? So this would be 5x squared minus 3x plus 2. And the factors that we have on the denominator are x times x, so that's the repeated factor, times x minus 2. So what we're used to is we take a over x plus b over x, right? Plus c over x minus 2. But notice we can go ahead and combine the first two fractions because they have the same denominator. So we get a plus b divided by x plus c divided by x minus 2. So remember, what we would do in order to solve this is we would multiply by the entire denominator, x squared, x minus 2. So on the left-hand side, we get everything cancels out. So we're left with 5x squared minus 3x plus 2. With our first term, one of the x's cancel out. So we have a plus b times x plus minus 2. And then for our c term, we get x minus 2 cancels out, and we're left with x squared. So now we can go ahead and solve 5x squared minus 3x plus 2. Let's simplify the right side, a plus b, and that's going to be x squared minus 2x plus cx squared. We can go ahead and distribute that a plus b out, right? That becomes ax squared minus 2ax plus bx squared minus 2bx plus cx squared. So let's go ahead and combine common terms. So for our x squareds, we have a plus b, and we also have plus c, and those are our x squared terms. Let's combine our x terms, so that's going to be negative 2a minus 2bx, and then there are no scalars. So remember, the left and the right side need to be completely even. So that means our x squared terms have to be the same. It also means our x terms have to be the same and our scalars have to be the same. So let's go ahead and set this up. It's going to be three equations, right? First, we have that 5 has to equal a plus b plus c, right, in order for those terms to be the same. And then we also have that negative 2a minus 2b has to be equal to negative 3. And then finally, our scalars have to be equal, in which we have 0 is equal to 2. Notice here, this is not a true statement. 0 is not equal to 2, which means this method is not going to work out for us because we're not going to get a solution. So that's why it's an issue. So here we have what we should do instead. So instead of doing what we just did, we're going to go ahead and try where we square one of the terms. So instead of x and x, we have x and x squared. It doesn't make a difference actually because remember, we're combining these on the right side in order to equal the left side. So it doesn't make a difference if one of them is squared and one of them is not, right? We can still combine them and add them together in order to get the left side. So let's go ahead and try this out. I'm going to go ahead and multiply the entire thing by the denominator, x squared x minus 2, and let's see what happens. We get 5x squared minus 3x plus 2 is equal to a times x minus 2, right? And now with b, that entire x squared cancels, and we have x minus 2 plus c times x squared. Let's go ahead and multiply this out. Alrighty, so I multiplied it all out. Let's go ahead and combine common terms. So we have 5x squareds, we have negative 3x's, and 2 scalars is equal to a plus c, that's our x squareds. Let's combine our x's, negative 2a plus b. Yep, that's all. And then for our scalars, we just have negative 2b. So let's go ahead and set them equal to each other. So our x squareds are going to have to equal 5. Our x's are going to have to equal negative 3, and that should be an x right there. And then finally, our scalar negative 2b should equal 2. So let's go ahead and set up these three equations. So first we have that a plus c has to be equal to 5, right? Because that's how many x squareds we have. For those purple terms, negative 2a plus b has to be equal to negative 3. And then finally, negative 2b has to be equal to 2. So the point of squaring it is so now we get a scalar term, right? We don't have 0 is equal to 2. We have negative 2b is equal to 2. So here we can solve for b. b is going to be equal to negative 1. And we're just going to move to the left, and we're going to take negative 2a And now we can plug in our b, which is equal to -1, is equal to -3. So adding over that 1, I get -2a is equal to -2, which tells us that a is equal to 1. Okay, and then we have one more here. We have a, which is equal to 1, plus our c is equal to 5. So if we subtract over that 1, we get c is equal to 4. And so here we have what our terms are equal to. And that's going to help us out with this first problem because now we're going to go ahead and integrate it. So now that we already did the partial fraction decomposition, we're going to go ahead and set this up in our integral. So we have a over x, so 1 over x, plus b over x, which is going to be -1 over x squared, and then plus c over x minus 2, that's going to be 4 over x minus 2 dx. So remember, this guy right here is going to be -1 times x to the -2, or -x to the -2, right? So when we integrate this, we're going to get the natural log of x, and then that's going to be minus add on to the exponent, divide by that new exponent, and then plus 4 natural log of x minus 2 plus some constant c. And if you wanted to rewrite it, you totally could. So that's going to be plus 1 over x plus 4 natural log of x minus 2 plus c. And so that's how we can use partial fraction decomposition with repeated terms. You take one of the terms and you write it normally. So we have an x, and then you take the other one and you square it. So let's go ahead and try it again. Now we have x plus 3 all to the power of 2, and that's going to be our repeated term. So first, of course, we're going to do partial fraction decomposition. So I'm going to rewrite this. So we get a, we take our term like normal, x plus 3, plus b, and now this one's going to be over x plus 3 quantity squared. So now I'm going to multiply by the entire denominator. I get x is equal to, one of those x plus 3 cancels out, and we're left with one remaining, and then both of those cancel out. So this one's actually very nice. So let's go ahead and solve it through. We have ax plus 3a plus b, and actually this is already separated, right? This is our scalar, and this is our x value. And notice here on the left that we actually don't have any scalars, so we have plus 0. So that tells us our a is going to have to be equal to a 1, right? There's a leading coefficient of 1 right there. And 3a plus b is going to have to be equal to 0. So let's write that down. A has to be equal to 1. So then we can plug that in here. 3 times our value of 1 plus b has to be equal to 0. So here we get 3 plus b equals 0. So b is equal to -3. So let's go ahead and rewrite our integral. So we have the definite integral from -1 to 1. And now we can split this up. So we get a over x plus 3, 1 over x plus 3. And now that's going to be minus 3 over x plus 3 squared dx. So remember, this is just going to be -1 to 1, 1 over x plus 3. And you can rewrite this as -3 x plus 3 to the -2. It's just like x to the -2, it's just x plus 3 to the -2. And we know how to integrate this. So here we get the natural log of x plus 3 minus 3, and that's going to be x plus 3 to -1 divided by -1, evaluated between -1 and +1. So I'll go ahead and rewrite this first. So now that we have it nicely written out, we can go ahead and plug in upper minus lower. So I'll go ahead and write that out. So first we can combine natural log of 4 minus natural log of 2. If we use natural log rules, that's natural log of 4 divided by 2, which is just equal to 2. And then here we have, I'll go write it on the side, 3/4 minus 3/2. So that's going to be equal to 3/4 minus 6 divided by 4. So that's going to be minus 3/4. And that right there is our solution without a calculator. You can, of course, calculate it out if you wanted to. So now let's go ahead and try one more. So we are actually going to have to factor this one. So let's go ahead and do that. So what I'm going to do is, out of these first two terms, I'm going to factor out an x squared. So I get x squared, and that's going to be x minus 2. And then out of my second two terms, I'm going to factor out a -4, so minus 4. And that is going to be x minus 2 dx. So they both have a common term of x minus 2, so I can factor that out, and I'm left with x squared minus 4, which is a difference of squares, and we can actually rewrite that. So it's going to be x minus 2, and that difference of squares is x minus 2, x plus 2. So notice we have a repeated term of x minus 2. So let's go ahead and set up our partial fraction decomposition. So we get a over our normal x minus 2 plus b, and now we take our repeated term and square it, and then that x plus 2 is totally fine. It's just hanging out. We get another term. So now we're going to multiply by the entire denominator, so we're left over with 1 on the left side. We get a times 1 of the x minus 2 times x plus 2. And then for b, we only have x plus 2 left over. And then for c, we have x minus 2 squared left over. So I'm not going to go ahead and, multiply this whole thing out. Instead, I'm going to go ahead and use a shortcut for this one. So like I said, you can use either way, but we're going to go ahead and use a shortcut. I like to do that when we have like longer terms like this. What we're going to do is plug in x's, and those x's should be one of the zeros. So here, notice one of the zeros here is going to be 2. If I plug in 2, that's going to go to 0. So I'm going to plug in x is equal to 2. On the left side, we have 1 because that's not going to change at all. The a term is going to go to 0, and then we have b times 2 plus 2. And then that c term is also going to go to 0 if I plug in 2. So 1/4 is equal to b. So now let's go ahead and try plugging in another 0. So I notice here we have x plus 2, and if I were to plug in -2, that would go to 0. So let's try x is equal to -2. On the left side, we still have 1. That a term is going to go to 0. The b term is going to go to 0, but our c term is not. So that's going to be -2 minus 2 squared. So that's 1 is equal to, that's going to be 4 squared, which is 16c. So 1/16 is equal to c. So we have our c, we have our b, but we're missing our a. And there's no more zeros that we can plug in, right? Our only zeros are positive and -2. But since we already have 2 of the values, we can just plug in any value and we can solve for it. So let's just plug in x is equal to 0. We get 1 is equal to a -2 times 2 plus b, and that's just going to be 2, plus c -2 squared. But we know what c and b are equal to, so we can also plug those in. So we get -4a plus b is equal to 1/4, which is multiplied by 2. And then c is 1/16, and that's multiplied by 2 squared, which is 4. So here we can simplify this out. We get 1/2 plus, that's going to be 1/4. So we get 1 is equal to -4a plus, and then that is going to be equal to 3/4. Subtracting 3/4 from both sides, I get 1/4 is equal to -4a. Dividing both sides by -4, I get -1/16 is equal to a. And so using those first terms and plugging in another x value, we're able to find our third term. So that's another way that you can use a shortcut. Of course, you can multiply this whole thing out and solve, and you're going to end up with the exact same solution. So it's whatever your heart desires. But let's go ahead and set up our integral now. So I need to zoom out so I can see my terms. Okay, so it's going to be -1/16 divided by the normal x minus 2, and then plus b. So b is equal to 1/4, and this one is the x minus 2 squared. And then c 1/16 divided by, that's going to be the x plus 2, dx. Just a reminder that this is going to be x minus 2 to the -2, so we're going to go ahead and use power rule when we take that antiderivative, right? Sorry if that's messy, but whatever. So here we get -1/16 natural log of x minus 2, and that's going to be plus 1/4 x minus 2, add 1 to the power, so that's -1 divided by that new power, plus 1/16 natural log of x plus 2 plus c. If you're on a test and it said not to simplify, I would leave it like that, but we're not taking a test right now, so we're going to go ahead and try to simplify it. The first thing I notice is that we can actually combine these two natural logs since they have the same scalar. So that's like rewriting it 1/16 natural log of x plus 2 minus natural log of x minus 2. And then this is going to simplify to minus 1/4 x minus 2 plus c. And when we subtract natural logs, we can actually divide them. So that's going to be 1/16 natural log of x plus 2 divided by x minus 2, and then minus 1 over, you can multiply that through, 4x minus 8 plus c. And so that right there is our solution. I mean, any part of that, whatever you like to simplify it to. So that's all I have for us in this video today. If you enjoyed it, I have many more like it, so make sure to check out my playlists. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.